For all problems like this, we're using the graph that they give us to find either x values or y values. That's all we're looking for. And remember, x values run left and right, y values run up and down. When we're given something of the format f of 2, what they're giving us is an x value of 2. So what I need to do is find the y value on the graph where x is 2. So I'm going to go over to 2 on the x-axis, and my point is right there on the x-axis. I didn't have to go up or down at all to hit this blue graph. So since I didn't have to go up or down, my y value is 0. So that's all I'm doing. I have an x value here. I've found the y value for the point that lies on this graph. For the domain, what I'm looking for is all possible x values. So that might lie on this graph. The graph goes forever in the direction to the left. I mean, it gets extended. It has no end. So like if I picked a negative 100 out here somewhere, there would be some point up at the top that would have that x value. So there is no limit to the lower end of my domain. So it goes in the negative direction forever. So negative infinity is what we say. To the right, we have the same thing going on. It goes to the right forever. I could pick 1,000 out here, and there would be some y value way up here that would satisfy that. So since this goes forever to the right, we say it goes to infinity. There's no breaks in it. Every x value is covered by this graph somewhere. So our domain is negative infinity to infinity. We always use parentheses on the interval when infinity is involved, because infinity is something we can never reach, and the parentheses imply that we never reach the endpoints. For part C, we're asked what x values are there where f of x equals 1. Well, this is just the opposite of part A. This time they're giving us a y value of 1, and we want to find the x's. So I go up 1 on the y-axis. Well, I can go over 1 and hit the blue graph there. So positive 1 is one of my x values. I can keep going over 2, over 3, and we can see that 3 is another of my x values. So there may be more than one answer for this question, because as we see in this case, there are 2 points on the graph that have a height of 1, and that's at the x value of 1 and the x value of 3. The range, like the domain, is all possible y's. So, and we always read the range, we read the domain from left to right, we read the range from bottom to top. Well, this graph does not go down forever. It does have a minimum right here. Now what we have to be careful of is the range is all possible y's. What is the y value of this point? Well, if I write the ordered pair of that point, I went over 2, up 0. Which of those is the y? The y is the 0. So that is the number I want to use as my lower bound, the 0. A lot of people want to put the 2 because it's on 2 on the x-axis, but range is all possible y's, not all possible x's. So our bottom value is 0. We actually hit that. There's a solid point there. When we reach at one of our boundaries, we put a bracket there instead of an infinity, or instead of a parenthesis, I'm sorry. Now the upper bound, how high does my graph go? What upper y is the limit? Well, this graph goes up forever. No matter how high I pick a y value, I could pick whatever y value I wanted to. 1,000 up here, and there would be some x value associated with it here and here. So there's no limit, upper limit, on what my y's can be, so I say it goes up to infinity. And again, even though the left-hand side had a bracket, the infinity always gets a parenthesis, because infinity is something I can never reach.